Hi guys, today I want to share with you a heartbreaking story that holds the essence of the hope, gloom and reality of scientific progress. It is a story of a young girl. Her name was Uditi. Her journey through a rare neurodegenerative disease has left a deep-rooted mark on the rare disease research and gene editing. In New Delhi, India, Uditi was living a vibrant life. As a young girl, Uditi was always excited and full of energy. Her parents adored on their precious daughter, delighting in her curiosity and love of celebration. Uditi greeted each day, each festival, each birthday with excitement, buzzing around for hours, getting ready, peppering her mother with excited requests. She greeted family and friends with hugs and kisses, bringing joy to party with her laughter and dancing. Then suddenly a flicker of darkness crept in. Uditi began experiencing moments where she zoned out, staring blankly for a few seconds before snapping back to herself as if nothing could happen. Her mother intently wondered she should worry. The flickers intensified into a unique seizure. One day, 9-year-old Uditi simply dropped a camera, staring at it in confusion as it crashed to the floor. In that chilling moment, her mother knew her worst fear was realized. Something was wrong with her daughter. After an annoying diagnostic, Uditi parents received a crushing news. Their daughter had an extremely rare neurodegenerative, untreatable genetic brain disease called FENIB. A single mutation caused toxin protein clump into form in Uditi brain cell, triggering neurodegeneration and dementia like a symptom. So FENIB is a rare genetic disorder that causes progressive brain damage and dementia. The mutation in neuroserpin gene lead to an accumulation of toxin protein in the brain cells, gradually destroying them. The news destroyed Uditi's dream and aspiration. With no known cure or effective treatment, most patients surrender their life within a decade of symptom onset. For Uditi and her family, the diagnosis was a devastating blow, but they refused to surrender to despair. Uditi's parents desperately searched for any information, any glimmer of hope to grip to about this nasty disease they had never heard before. But the diagnosis was grim. FENIB harshly robbed Uditi's ability until her brilliant mind is trapping in falling body. The family tried every possible intervention like a special diet, alternative therapy and a stream of doctor and medications. But nothing could stop Uditi's progressive decline. Her seizure impaired, her muscles seized up, robbing her ability to walk, to see clearly, to hear. The bright light that had illuminated their world slowly dimmed as her brilliant personality faded. In 2018, Uditi and her parents moved to New York, United States, hoping to find the answer. There, they met Dr. Orrin Devinsky, who mentioned a potential experimental treatment using the revolutionary CRISPR gene editing technology to correct the mutation causing Uditi disease. Devinsky also emphasized the difficulty. At that time, the base editing, which was first reported in 2016, had never been tested in clinical trial. So Uditi's father latched onto the slim read of if scientists could plan a way to edit the DNA of Uditi's brain cells and stop her brain cells from the producing toxic protein, maybe, just maybe, it could halt her devastating decline. In December 2019, the family relocated to India. In January 2021, as the COVID-19 pandemic surged, Uditi was hospitalized with severe COVID-19. After spending 20 days in hospital, her health never fully bounced back. Uditi began to struggle with communication. Her parents decided to speed up the base editing project by funding a second team in India. They connected with researchers like Dr. Arka Subra Ghosh, who had the daring vision to attempt developing the world's first CRISPR treatment for a patient with a rare genetic brain disorder. Dr. Ghosh is a researcher at CSIR Institute of Genomic and Integrative Biology in New Delhi. In June 2023, Dr. Ghosh and his collaborator delivered an update to Uditi parents that both boosted their hope and plunged them into the gloom. His team was making rapid progress towards a unique CRISPR gene editing to modify the DNA in Uditi's brain cells and prevent them from producing a toxic protein. I can give you the brief detail about the CRISPR. So CRISPR is cluster regulatory interface short palindromic repeats. This is a revolutionary gene editing technology that allows researchers to precisely edit the specific section of DNA. However, using CRISPR for an in vivo editing in the human brain had never been attempted before, and the risk was significant. So coming back to Uditi's story, Uditi family with no other viable treatment option and Uditi condition rapidly deteriorating placed their hope in the hand of this daring researcher, and her mother even urged the researcher to work faster, desperate to save her daughter's life. The team worked tirelessly, driven by the knowledge that every day counted in the battle against FENIB brain disease. The challenges they faced were numerous and complex. So designing a CRISPR system capable of targeting neuroserpin gene in the brain was a massive task. They had to develop a safe, effective delivery mechanism to transport the CRISPR component into the brain, ensuring precise gene editing without off-target effects and addressing potential immune responses. So despite the daunting barriers, the researchers pressed on, fueled by the hope that their work would save Uditi's life and pave the way for future breakthrough in the treatment of rare genetic disorder. The race to develop a CRISPR therapy for Uditi highlights the significant challenge faced by researchers working on rare diseases. Funding for a rare disease research is often uncommon, as pharmaceutical companies prioritize more common conditions with a larger potential markets. The development of personalized therapy for ultra-rare disease like FENIB is incredibly complex and resource-intensive, making it difficult to attract the necessary funding and support. Each patient's genetic makeup and disease manifestation may require a unique approach, further complicating a process. Standardization and the streamlining of the procedure are challenging, as each case presents its own set of variables and complications. Despite these challenges, researchers like Ghosh and his team perseverance, driven by a passion for scientific discovery and desire for alleviate human suffering. Their work serves as a treatment to the resilience and determination of scientific community in the face of obstacles. In October 2023, just as the team prepared to begin final tests in mice, devastating news arrived. Uditi had fallen ill and slipped into a coma. Days later, the unthinkable happened. The brave young woman could not hold on any longer. Uditi passed away just months before she may have received the experimental treatment. Uditi's parent world shattered into a million pieces. The brilliant light that had illuminated their life for 20 fleeting years heartlessly ended before they could explore that last long sought hope of saving her. In their overwhelming grief, the only consolation came from knowing Uditi's spirit would live on, driving the scientists to push forward the work they have done the technique they have developed could still light the path for other families who battling through the rare genetic disorder. Tears streamed down Dr. Ghosh's face as he promised Uditi parents to continue the effort in her honor. Although Uditi could not be saved, the daring effort to develop a personalized CRISPR treatment for her laid the vital groundwork. It would help make future short gene therapy for the other rare brain diseases or feasible and accessible. At Uditi Memorial Service, her father tried to make sense of the harsh timing. His daughter had always been in a hurry, needing to be first at everything she did. Perhaps she was needed elsewhere to light another path toward future breakthrough. As her father looked at Uditi's radiant smile shining from the photos, he felt profound gratitude that her brilliant spirit could never be ended. Her passion for life, her unwavering determination in the face of darkness would live on as endless flame. It would fuel the effort of scientists like Dr. Ghosh, who promised to work relentlessly to cut the cost and streamline gene editing therapy so they become accessible for every patient no matter how rare their condition. It would inspire other families in India and around the world battling rare diseases that have been left behind by pharmaceutical companies fixated on the stream on treatment for the masses. Most of all, Uditi's shining light would illuminate the truth that no life is too small, too brief to make an everlasting impact. The path she lighted from the moment she entered in the world until she departed from it far too soon would burn forever, guiding humanity to a future where even the rarest disease can be unraveled by the code of life itself. While Uditi's life was tragically cut short, her story has left an indelible mark on the scientific community and the world of rare disease research. Her story has also served as a powerful reminder of a human life at stake in the race against the rare disease. Behind every statistic and the scientific experience are individuals like their dream and aspiration hanging in the balance, their family desperately seeking the answer and solutions. In the year to come, as breakthroughs are made and the lives are saved, Uditi's name will be remembered as a symbol of hope and the unwavering pursuit of scientific progress in the face of seemingly challenging odds. While the outcome for the Uditi was heartbreaking, her legacy will live on, inspiring future generations of scientists to continue the fight against rare disease with hope, perseverance. So thank you for watching and see you in the next video.